Hello, everybody, and welcome to this week's lesson. This week we're talking about ratios and fractions. We're going to be building on some of the skills that we worked on last week, so make sure you have worked through last week's lesson and tried the assignments up on Google Classroom before you get to this week's lesson. For our lesson today, you'll need your welcome packet. So that's the packet with your formula sheet, your multiplication table, all that good stuff. You'll want something to write with and some paper, and also a calculator. Our learning goals for this week are, by the end of this week, you'll be able to solve real-world arithmetic problems using ratios, compute unit rates. So for example, stuff like unit pricing, constant speed, people per square mile, and BTUs per cubic foot. And you'll be able to order fractions, including ordering on a number line. So let's get started with a warm-up problem. I want you to take a moment to pause the video and try the two problems on the screen here. And then when you're ready, come back to the video and we're going to work through them together. All right, so number one says, what is the GCF of 12 and 18? So what does GCF stand for? That's something we worked on last week. We talked about GCF last week, and that stands for greatest common factor. GCF is greatest common factor. So if you had trouble remembering what that means, I would again go back to last week's lesson and take a look at probably the last 15 to 20 minutes of that video. So greatest common factor, we want the greatest common factor of 12 and 18. We're gonna start by thinking of factors of 12, thinking of factors of 18, and then determine what is the greatest factor that they have in common. So we'll first list the factors of 12. We know there's going to be 1 and 12. We're going to have 2 and 6. And finally, we'll have 3 and 4. So those are the factors of 12 written out in order from least to greatest. And then let's do the same thing for 18. So factors of 18, well, we're definitely gonna have 1 and 18. And then 2 and 9. And finally we have 3 and 6. So that's a complete list of all the factors of 18. Now what is the GCF? The GCF is 6. 6 is the largest factor that they have in common. Now they have other ones in common. They have other common factors, but 6 is the greatest common factor. So 6 will be our final answer here. All right, number 2, what is the LCM of 4 and 8? So LCM, again, think back to our lesson last week. What does LCM stand for? LCM stands for least common multiple. So we're no longer talking about factors. Now we're thinking about multiples. So we'll get started by thinking of multiples of 4. Multiples of 4. Well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And we could keep going, but I'm going to stop there because that'll be enough for us. And then let's think about multiples of 8. Well, 8 times 1 is 8. 8 times 2 is 16. Again, I'm going to stop there because we've got enough to determine our answer. We want the least common multiple, the smallest multiple that these two numbers share. In this case, that is 8. 8 is the least common multiple of 4 and 8. So LCM is 8. Now we're going to be returning to GCFs and LCMs later in this lesson, so make sure you keep them at the front of your brain for later on. All right, so our main topic today is ratios. We're going to be talking about ratios in general, and then also talking about a couple special types of ratios, which you're probably already pretty familiar with. So a ratio is a comparison of two numbers. Anytime you're making a comparison between two different amounts, you are thinking of a ratio. Now ratios can be written in a few different ways. So sometimes we write them with words. For example, we might say 3 to 5. Sometimes we write them using the colon symbol. So 3:5, we would just say 3 to 5. And sometimes we write them in what we think of as fraction form. So using the fraction bar, again, we'd have 3 to 5 or 3/5. So let's think of some real life examples here. The first one I have is the score was 10 to 14. Right? We're watching a game, talk about the points of the two teams. Second example, there were 5 campers per counselor. So we've got 5 campers and how many counselors? 1, right, per counselor. So that's a ratio of 5 to 1, 5 campers to 1 counselor. Example 3, you need to add 1 tablespoon of bleach per gallon of water. So that's a 1-to-1 ratio of bleach to water. Now, often ratios are simplified or reduced to lowest terms. So for example, let's say I'm at camp and I see 10 campers and 2 counselors. So there are 5 campers per counselor. I just reduced that ratio of 10 to 2. I took that ratio of 10 to 2 and I reduced it to 5 campers per counselor or 5-to-1 ratio. So let's take a closer look at simplifying ratios. Why do we do it? Well, the main reason is that smaller numbers are easier to understand, they're easier to talk about and communicate with each other about. So that's the main reason. We just, as humans, prefer dealing with smaller numbers. The other reason is that it's something that you'll need to do on the GED test. So it's a skill you need to practice in order to do well on this test. So how do we simplify a ratio? Well, if we're thinking of it in fraction form, so top number and a bottom number, we simplify by dividing the top and the bottom by the greatest common factor. So that's where GCF is coming in here today when we're thinking about simplifying ratios. Let's look at this example here at the bottom. Let's say we have the ratio 6 to 8. The first thing I'm going to do is I'm going to rewrite it with the fraction bar, so 6/8. Next thing I'm going to do is I'm going to determine the GCF of 6 and 8. So take a moment to think about the GCF of 6 and 8. So the GCF of 6 and 8 is 2. That's the largest factor that they both share. And so finally, I will take my ratio and simplify it using the GCF. I'll do that by dividing both the top and the bottom by 2. And so I'm left with 3 to 4. So the ratio 6 to 8 simplifies to the ratio 3 to 4. All right, let's get some practice. So in these two practice problems, you want to write each ratio as described and simplify your final answer. Pause the video to give these problems a try, and then when you're ready, come back to the video and we're going to go through them together. All right, so number 1, there were 2 teachers and 12 students. Write the ratio of teachers to students. So we're being asked to write the ratio of teachers to students. I want to pay careful attention here to the order I'm being asked to write my ratio in. It doesn't say students to teachers, it says teachers to students. So my teacher number should come first, my student number should come second. Or my teacher number should be on top and my student number should be on the bottom. So we've got 2 teachers to 12 students. And now we want to simplify. How do we simplify? Well, we identify the GCF of our 2 numbers. In this case, it's 2. Both of these numbers are divisible by 2. And so we will get a simplified ratio of 1 to 6. So 1 teacher for every 6 students. All right, number 2. During their swim lesson, Alicia swam 15 laps and Jonathan swam 10 laps. What's the ratio of Jonathan's laps to Alicia's laps? Okay, so again, I'm going to pay close attention to the order that I'm being asked to write my ratio in. It says ratio of Jonathan's laps to Alicia's laps. So Jonathan first, Alicia second. Jonathan did 10 laps and Alicia did 15 laps. So 10 to 15. And now let's simplify. So we determine the GCF of 10 and 15. The greatest factor that those 2 numbers have in common is 5. They're both divisible by 5. And if you're having trouble coming up with factors for these numbers, you should definitely have your times table out next to you. And that also probably means you should be practicing with your times table and practicing with your basic division facts. So if you want to chat about some good ways to practice those things, send me a message and we can definitely talk about it. All right, so we are left with 2 over 3. So if Jonathan swims 10 laps and Alicia swims 15 laps, that means Jonathan is swimming 2 laps each time Alicia swims 3 laps, 2 to 3. All right, so first special type of ratio that we're going to talk about is unit rates. So a unit rate is a comparison to 1. So not just a comparison of any 2 numbers, but where you are comparing a number to 1 of something. So some examples of unit rates. There were 5 campers per counselor, right? We already saw that example earlier. So that's a unit rate. Example 2, gas is $1.79 per gallon, right? So per 1 single gallon. I can buy 2 pounds of bananas for $1, right? 2 pounds for $1. So unit rates are a common way of making comparisons, and they can be useful for calculations. They're especially useful if you are trying to compare prices or find the best deal for something. So for example, if you're trying to find the best price for gas, what you're doing is you're comparing unit prices, right? Maybe over here it's $1.79 per gallon, and over here it's $1.84 per gallon, and over here it's $2.01 per gallon, right? You're comparing unit prices of those. So how do we calculate a unit rate? If we just have a regular old ratio comparing 2 numbers and we want to get that special unit rate, how do we calculate it? Well, we just divide. There's gonna be a lot of dividing today. So, for example, if Terrence drove 600 miles in 8 hours, what was his average speed in miles per hour? So, this problem starts off by giving me this ratio of miles and hours, and then I'm being asked to figure out the miles per hour. So I'm being asked to figure out the unit rate here. So first thing I'm going to do is I will set up my ratio just so I'm clear on what it is I'm comparing. I want miles to hours, miles per hour. So miles first and hours second. And then the second step is just to divide. So 600 divided by 8, you could do that by long division, or you could do it with a calculator. 600 divided by 8 is, so if you put it into the calculator, it's going to look like this. 600 divided by 8 is 75. And so his average speed in miles per hour was 75 miles per hour, per 1 hour. Another way you might write that, or you might see it written, is just 75 mph, miles per hour. All right, let's get some practice. So number 1, Darnell paid $8.20 for 4 pounds of potatoes. What was the price per pound? Price per pound, so dollars per pound. I'm going to set up my ratio of the numbers I'm given. So the price and the number of pounds. And then I'm going to divide. So 820 divided by 4 is $2.05. So this becomes $2 per pound. Sorry, $2.05 per pound. Per 1 pound. Or you could write it like this. You might see it written like this for a unit price. We would call this a unit price, the price per unit of something. So unit price, it might look more like this. If you're reading like the sticker at the grocery store that has all the pricing information, you might see it written like that. All right, number 2, there are 100 people living on a 10 square mile piece of land. I forgot to type that in earlier, a 10 square mile piece of land. How many people are there per square mile? So I want people, right? How many people are there per square mile? So I'm going to start with people, 100 people, divided by 10 square miles. And so my people per square mile will be 100 divided by 10 is 10 people. Just going to abbreviate that, 10 people per square mile, per 1 square mile. And instead of writing out square miles, I'm going to abbreviate it like this, miles squared with the little 2. All right. So unit rates are one very useful type of ratio. Another type of ratio that we use very often are fractions. So a ratio is just a general comparison of 2 numbers. A fraction is a comparison of a part to a whole. So we're comparing some number of parts to total parts in a whole. Fractions are always written, or usually written with the fraction bar, where we've got a number on top and a number on the bottom. The number on top is called the numerator. The number on the bottom is called the denominator. The denominator represents the total number of equal parts in the whole. So whenever we're talking about fractions, right, we're talking about taking something and cutting it up into little pieces. Those pieces must always be equal. And then the numerator is the number of parts that you were interested in, or the number of parts you're talking about, the number of parts that the problem is talking about. So let's look at these two pictures down here at the bottom of the screen. In this first picture, the picture on the left-hand side, the whole big rectangle is split up into 4 parts, and the parts are all the same. There's 4 equal parts. So this is something that I could start talking about in terms of fractions. Let's say I colored in one of the parts. Just imagine the whole thing is colored in. If I colored in one of the parts, then I would say that 1/4, 1 out of 4 parts is colored in. So 1 out of 4. 1 out of a total of 4 equal parts is colored in. But over here on the right-hand side, I see I've got this large rectangle, but it's broken into pieces that are different sizes. So it's not going to be as clear if I start comparing parts to the whole. It's not going to be as clear exactly what amount I'm talking about because the parts are all different sizes, right? So if I'm talking about one part, this big one on top here, that's going to be very different than if I'm talking about this little part next to it. All right, so just as with regular old ratios, we also often simplify our fractions or reduce them to lowest terms. And for the same reasons, because smaller numbers are easier to understand, easier to work with, easier to think about. And also because you will be asked to simplify your fractions on the GED test. So if you're doing a problem where your final answer is in fraction form, that final answer should always be simplified or reduced. So how do we simplify them? The same way we simplify any ratio, by dividing the top and the bottom by the greatest common factor. So let's look at the example at the bottom here. It says simplify 2/4, or 2 out of 4. So first thing we'll do is determine the GCF of 2 and 4. The greatest common factor of 2 and 4 is 2. You got it. Greatest common factor is 2. So I'm going to take my fraction. I'm going to divide the top and the bottom by that GCF. Two divided by 2 is 1. And 4 divided by 2 is 2. So we have just seen that 2/4 is equivalent to 1/2. 2/4 is equal to 1/2. Now think about it. If you have 2 quarters, if you have 2 quarters in your pocket, you got $50, right? You got 50 cents, $50. So 2 quarters is the same as 1/2. And we can see that if we think about these 2 drawings here, these 2 pictures. So let's look at the first one. This first big rectangle is cut up into 4 equal parts. And so we started out this problem by talking about 2 of those 4 parts, 2 out of 4. So there's 1, and there's another one. Now, if you are coloring this in, I'm sure you would do a much neater job than me. But it doesn't have to be beautiful. It just has to have a clear meaning. Okay, so this first picture is showing us 2/4. Well, now let's go to the second picture here. What if I want to show 1/2? Well, I'm going to end up coloring in the same amount of the rectangle. So let's see that. This must be like watching paint dry. But what you could be doing right now as you watch this is you could also be drawing your own pictures. Right? So you don't want to just be sitting and passively listening, because that won't help you remember as well. You should be following along, taking notes. Anything that I write down, you can also write down. Okay, so let's compare these two pictures. On the left-hand side, we have this picture that shows 2/4. And on the right-hand side, we have this picture that shows 1/2. But we can see that even though the rectangles are sliced up differently, the amount of red in each picture is the same. So when I'm talking about fourths, I've got something cut up into 4 parts. When I'm talking about halves, I got something cut up into 2 parts. But if I've got 2 out of 4 or 1 out of 2, it's the same amount of stuff. All right, let's get some practice. So I want you to try simplifying each of these fractions. And when you are done, you want to come back to the video. So number 1, simplify 12/18 or 12 out of 18. What's the first thing we do? First thing we do is identify the GCF of 12 and 18. Well, lucky us, we already did that in our warm-up problem today. So the GCF is 6 for 12 and 18. So I'm going to divide top and the bottom by 6. And so I get 2/3. So we just saw that 12/18, 12 out of 18, is equivalent to 2 out of 3, 2/3. All right, number 2, 7 and 21. What is the GCF of 7 and 21? It's 7. So we're going to divide the top and the bottom by 7. So our reduced fraction will look like 1/3, 1/3, 1 out of 3. So we just showed that 7 out of 21 is equivalent to 1 out of 3. All right. So just as we can simplify or reduce fractions, we can also raise fractions. So in the first example with simplifying, we took 2/4 and we turned it into 1/2. But we can work in the opposite direction. So we can start with 1/2. Right, if I colored this part in, I'm not going to make you watch me slowly color it in again. 1/2, we can take that and we could transform it into 2/4 by just adding that extra slice down the middle. Right, so by like taking out our pizza cutter and adding that black line through the middle. So 1/2 is 2/4. And the way that we do that mathematically or with a calculation is we raise fractions by multiplying the top and bottom by the same number. So we reduce by dividing, we raise by multiplying. So if we didn't feel like drawing pictures, but we had 1/2 and we knew we wanted to change it into 4ths, we would multiply the top and the bottom by 2. Excuse me. multiply the top and the bottom by 2. 1 times 2 is 2. And 2 times 2 is 4. All right, so we're going to be using that skill of raising fractions for what comes next. So comparing fractions, the skill of being able to raise and lower fractions is going to be useful. So why? Well, it's because fractions are easier to compare if they have the same denominator. Now, why is that true? Well, think about what the denominator means. What does the denominator mean? The denominator tells us how many parts are in the whole. The denominator tells us how many parts are in the whole, the total number of parts. And so it also kind of tells us about the size of those parts, right? Because if you take a pizza and you start cutting it up into more and more pieces, the pieces are going to get smaller and smaller. So the denominator tells us about the number of parts in the whole, but it also gives us a little information about the size of the parts. So if you have fractions with a different denominator, let's say you have one pizza that's cut up into fourths, and you have another pizza that is the same size, just pretend those are exactly the same size pizzas. Another pizza that's cut up into sixths. Well, the pizza that's sliced into fourths has bigger slices than the pizza that's sliced into sixths. So if we were going to try and count up the total number of slices we had, or if we were going to compare how much I ate of my pizza compared to how much you ate of your pizza, it would be much easier if all of the slices were the same size instead of different sizes. Our goal when we're trying to compare fractions or when we're trying to add or subtract fractions, our goal is to have the same denominator. Our goal is to be talking about the same size slices for every fraction. And that is called finding a common denominator. So when you have a group of fractions that start over there, lost my train of thought. So a denominator that a group of fractions share is called the common denominator. It's called a common denominator. Usually, when we talk about working with two or more fractions, we're going to be talking about the least common denominator that all of those fractions share. Now, why? Why would we talk about the least common denominator? Well, you might be able to guess already. It's because we prefer smaller numbers. So fractions will have more than one common denominator, but I'm going to show you how to find the least common denominator just because in general, we prefer smaller numbers over bigger numbers. Okay. So the least common denominator, when you want to find the least common denominator of a bunch of fractions, it's going to be the LCM of the denominators, the least common multiple. So I promised you we were going to be using GCF and LCM in this lesson. Here's the LCM. So for example, let's say you had a question that looked like this. Compare the pair of fractions below by using greater than symbol, less than symbol, or equal symbol. And our fractions are 2/3 and 3/5. First thing we're going to do is we're going to find the LCM of the denominators. So the LCM of 3 and 5. So the LCM of 3 and 5 is, well, if we think of multiples of 3 3, 6, 9, 12, 15. Now 15 kind of rings a bell. Let's think about multiples of 5. 5, 10, 15, right? So the first number, the first multiple that they have in common is 15. So 15 is the LCM. So my next step is going to be to raise my fractions to have that denominator. So let's start with 2/3. I'm going to raise 2/3 so that it has a denominator of 15. So remember, raising a fraction means we're going to multiply the top and the bottom by the same number. What number do we multiply by? Well, we multiply by whatever we have to in order to get 15. So 3 times what is 15? 3 times 5. And I just do exactly the same thing on top. So 2 times 5 is 10. So 2/3, 2 out of 3, is equivalent to 10 out of 15. Do the same thing with your other fraction. 3/5, 3 out of 5. We're going to raise it to have a denominator of 15. So what do we multiply by? We multiply by whatever we need to in order to get 15 at the bottom. So in this case, we need to do 5 times 3. So be careful here. We're not multiplying by 3 because 3 is the numerator. It has nothing to do with that. We're multiplying by 3 because we want to take 5 and transform it into 15. And then we just go ahead, we do the same thing to the numerator. 3 times 3 is 9. So now I've shown that 2/3 is the same thing as 10/15, and 3/5 is the same thing as 9/15. So now I've got two fractions with the same denominator. It's going to be a little easier to compare them. So 10/15 compared to 9/15. Is 10/15 greater than, less than, or equal to 9/15? 10/15 is greater than 9/15. So we'll use the greater than symbol there, right? That we would read this as 10/15 is greater than 9/15. And so I can return to my original two fractions, and I can say that 2/3 is greater than 3/5, right? Ever so slightly bigger. All right. The last thing we're going to do today is we're going to throw the number line into the mix here. So we talked about number lines last week as a tool that we use to visually order fractions. We use number lines quite often in real life. We talked about rulers, we talked about thermometers. So we can also use number lines to help us visually order numbers. So we're going to take these two fractions and we're going to plot them on the number line below. It says plot the fractions 2/4 and 3/8 on the number line below. First thing I'm going to do is I'm going to look at my number line, and I see that the whole number 1, so the space between 0 and 1, is cut up into 8ths. It's cut up into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So this number line is a number line that's showing me 8ths. And so the fraction 3/8, that's going to be really easy to plot because that already has a denominator of 8. So I can just go ahead and I can put that right on the number line. I'm going to put a point right on the number line at 3/8. So I've just plotted 3/8 on the number line. Now, let's think about 2/4. Well, 2/4 is not written in terms of eighths yet. So the question is, can we take our fourths and transform them into eighths? Can we do that? Can we take fourths and transform them into eighths? Yes, we can. We can do it by multiplying by 2, right? Because 4 times 2 is 8. So then I'll do the same thing to the top. We get 2 times 2 is 4. So 2/4 means the same thing as 4/8. So I'm going to go onto my number line and place a point at 4/8. And so we can see now, we can see that 2/4, right, which was the same thing as 4/8, 2/4 is greater than 3/8, right? It's greater than the blue point. It's closer to 1. So when you're dealing with a number line where you've got a whole number that's been broken up into parts, first thing you need to do is you need to figure out what are the parts it's been broken up into. So in this case, the whole number has been broken up into eighths, right? There's 8 equal parts between 0 and 1. And then you can start plotting your fractions on this number line once you know how they match up with the eighths that are shown on the number line, right? So 3/8, it was easy for us to put it on the number line because we saw 3/8 there straight away. 2/4, we needed to first convert 2/4 into eighths before we could put it on our number line. All right, let's get a little extra practice with this before we wrap up today's lesson. So, Angela, Belinda, and Cooper are comparing how far their pet turtles can walk in an hour. Angela's turtle walked 2/3 of a mile. Belinda's turtle walked 1/9 of a mile. And Cooper's turtle walked 3/6 of a mile. First, plot the turtles' distances on the number line below. Then, choose which turtle walked the farthest. Okay. So what's the first thing we should do here? First thing I'm going to do is I'm going to write out each of the fractions we're dealing with here. So Angela, her turtle was 2/3 of a mile. Belinda, her turtle was 1/9. And Cooper, his turtle was 3/6. Okay. So next thing let's look at the number line. So we're shown the space here between 0 and 1. So 0 is where they all start, right? 0 is where the race starts. And we're talking about fractions of a mile. So 1 would represent 1 whole mile. So this number line is talking about miles. Okay. And then I look at the space between 0 and 1, and I see that it's been broken up into 9 equal parts. Right, I've got 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, and 9/9 to get to 1 whole. So since I'm talking about ninths on my number line, I can actually take Belinda's turtle and I can plot that onto the number line right away. So Belinda, I'm going to put a point here at 1/9. and I'm gonna label it B for Belinda. Okay, so we got Belinda, she's all set. Now let's return to Angela. Her turtle walked 2/3 of a mile. We need to figure out how to take this 2/3 and get it onto our number line in terms of ninths if we can. So let's see, can we take 2/3 and turn it into ninths? What can we multiply 3 by in order to get 9? So 3 times 3. 3 times 3 is 9. Same thing up top, get 6. So 2/3 is the same thing as 6/9. So I'm gonna plot Angela's point here at 6/9, and I'll label it A. So 6/9, we know that that's also the same thing as 2/3. And now think about that for a minute. Let's imagine instead of 9 equal parts between 0 and 1, what if we just had 3 equal parts? Well, there would be 1, 2, 3, right? So we see 1/3, 1 out of 3 parts would line up with 3/9, and then 2/3, 2 out of 3 parts would line up with 6/9, and 3/3 would line up with 1 whole. Okay, now let's tackle Cooper's turtle. Cooper's turtle did 3/6 of a mile. Now, if you're already very comfortable with your simplifying of fractions, you might be able to look at 3/6 and think to yourself, well, 3/6, 3 is half of 6. So 3/6 must be the same thing as 1/2. And that's true. 3/6, if you reduce it, simplify it, you'll get to 1/2. Now, if you think about something that's cut up into 9 parts, right, 9, that's an odd number. You're not going to be able to split it in half evenly. If you look at the number line here, right, we got 4 out of 9, and then we got 5 out of 9. The halfway point is actually going to be right in here. It's not going to quite line up with 4/9 or 5/9, right? Because what's half of 9? Half of 9 is 4.5, right? 4.5. It's not quite 4, it's not quite 5, it's in between. So 3/6 is not actually going to line up with one of the little tick marks on our number line. It's going to be sitting in between 2 of the tick marks. Let's see what would happen if we tried to take our 6 and turn them into 9ths. So 6 times what gives us 9? Well, the answer is not obvious, I don't think. But if you did a little messing around on your calculator, you might be able to figure out that 6 times 1.5, so 6 times 1.5 gives you 9. But it's not straightforward, right? Because 9 is not a multiple of 6. 6 times 1 is 6. 6 times 2 is 12. So 9's not on the list. So you could do 6 times 1.5 to get to 9. I think it's easiest to look at the 3/6 and think of it as 1/2, because then you'd see that the 1/2, the halfway point, would be sitting between the 4/9 and the 5/9. Another way we can do this is we could try and think of a common multiple between 6 and 9. So what is the least common multiple between 6 and 9? The least common multiple between 6 and 9 is 18. So let's try changing our 6ths into 18ths. We would need to multiply by 3. So 3 times 3 is 9. So 3/6 is the same thing as 9/18, right? It's half. half of 18 is 9. And if you think about what it would take to make this and turn this number line into 18ths instead of ninths, well, you would just need to cut each of these parts into 2 parts, right? So this would be 1 18th, 2 18ths, 3 18ths, 4 18ths, 5 18ths, 6 18ths, 7, 8, right? 4 ninths would be 8 18ths. And then 9 18ths here, where point C is, 10 18ths, and so on. Right, so C is a good example of a fraction that's not going to exactly line up with the fractions that were already plotted for us on the number line, but we can, with a little bit of work, figure out where it belongs on the number line anyway. So we got point B here at 1/9, point C here at 3/6, or 1/2, or 9 18ths, or 4 1/2 ninths. Lots of different ways we could say it. And then point A there at 2/3. So we got all of our points on there. Let's finish up by tackling the last part of our question. It says choose which turtle walked the farthest. So which turtle walked the farthest? It's going to be Angela. Angela's turtle walked the farthest. Her turtle got the closest to 1 whole mile. Angela's turtle. All right, guys. Well, thank you very much for coming along on this lesson with me. What you're seeing on the screen now is a recap of what you have to work on this week. All of these are up on our Google Classroom throughout the week. So you've got a few posts on the Google Classroom to read through. There's going to be some links in there. So you've got our introduction posts, the vocabulary list and online learning links post. The vocabulary quiz will go up on Tuesday. Study skills will go up on Thursday. For assignments, these assignments, you should try them by Sunday evening at the latest. Earlier is better. You've got your problem of the day, which went up today, Monday. You've got worksheet Wednesday, which goes up on Wednesday. And then your problem of the day for August 28th, that will be up on Friday. And please remember to sign up for lab if you'd like to come in and work with me in person this week. You can send me a remind message. That's the easiest way to do it. Or you can hit me up by email or phone. All right. Again, thanks so much for joining me on this lesson, and I will talk to you all very soon. Take care.